half so that you have a little time to get started and we can work on it. There isn't, are we rolling? There isn't anything that you're doing today that you haven't done. Now, it's going to look a little different. So I'm going to try to explain how we go through this, all right? So this is continuation of 10-5 inverse matrices. Yesterday you did 2 by 2. Today you're going to learn how to do 3 by 3s. Okay, so given your matrix, now this is x, y, z. This is x, y, z equal to some answer here. I'm not worried about what the equal side is. This is just the coefficients on x, y, and z. It's a 3 by 3. Now I'm also gonna add 3 more columns. And it's the identity matrix. So this is a 3 by 6 matrix. 3 rows, 6 columns. This is the process to find your inverse. Alright, so this is the same process you would use on a 4 by 4, a 5 by 5, a 6 by 6, a 7 by 7, any size square matrix. Okay? You would set up your identity matrix attached to this. Now before you attach it, if you wanted to rearrange these rows, you could. I'm not going to, just because I'm just going to do it exactly the way it is and work through it. Now we take the whole board, because I'm writing big, to show you all this. It really only took me 4 steps, but I did multiple steps in each one. So if you did each step individually, you'll have about 10 matrices in your paper. I'm not going to go through the whole thing, but I'm going to start it because you already know how to do this. What is our goal? Our goal is to make your diagonals 1s and everything below and above them 0s. So I want those to be 0s, and I want these to be 0s, and I want my diagonals to be 1s. We did this back in section 2 and 3. Remember doing that? How do we change these? Well, we go this direction. We use the first row, and we made this 0, then we made this one 0, and then we made that one 0. Right? Yeah, you hated that, didn't you?
Yeah.
Well, this was the reason I had you do it in section 2 and 3. Okay, so that when we got to this point, maybe it's a little refreshing, you can do it a little bit faster, and go through. So I'm going to go through a couple steps, but I'm not going to do them all. Because when you get these 0s, then you could go ahead and make these 1s, or you could wait till the end. I would wait till the end to make these positive 1s. And then you go up this direction and make this a 0, that a 0, and that a 0. Okay? So the first thing I'm going to do is I want to make this a 0. So I could make that a negative 12 and this positive 12 and add these two together. Or I could multiply row 3 times negative 3 and add it to that, and that would be 0 then, wouldn't it? Alright, so this is the process you got to do. You have to look at your coefficients and figure out what you got to multiply them by to add to the other coefficients to make them 0. So I'm going to do a negative 3 times row 3 plus row 2. Alright? So I'll write it up here. Do a couple of these. So the first row is staying the same. So we have 4, 2, 3, 1, 0, 0. The second row is staying the same. Oh no, second row is changing. Third row stays the same. It's this one. This is the one that changes, if you remember. So now let's talk through this. Negative 3 times 1 is negative 3. Are we okay? Negative 3 plus 3 is 0. I'll write this in red so you know which one's changed. That's 0. Negative 3 times 0 is 0, plus 3 is 3. Negative 3 times 1 is negative 3. Plus 2 is what? Negative 3 plus 2. Negative 1. 0 plus 0 is 0. 0 plus 1 is 1. And negative 3 times 1 is negative 3. plus 0 is negative 3. So do you remember doing this process? Yes? Okay. Can you do this? Or do I need to do the whole thing? Okay. So you work your way down, you get this to be 0, then you work on this to be 0, because this won't be 0 after you change this one. And then you work up and work on those to get them to be 0. So let me show you the last step. After doing all those processes, here's what we end up with. It came out to, let's see, what's that? We did them all separately on here. It came out to something like this: 12, 3, and negative 1. And there were these were zeros. And I had, what was that? This is negative 60, negative 24, negative 36, negative 3, 3. Negative 2, negative 6. So this is what I ended up with after I did all of these operations. I got zeros at the bottom here, zeros at the top. Now how do I make those ones? You multiply by their inverses. Okay, so here I would take 1/12 times row 1, 1/3 times row 2, and a negative row 3 to make that a positive. Does everybody see why I did that? Okay, and then I ended up with this matrix when we were done. So we got 1, 0, 0, negative, I guess that was a positive, positive 3, negative 2, negative 5. And then we had 0, 1, 0, and that's negative 1, 1, 1, yeah. And at the bottom, 0, 0, 1, and this became negative 3, 2, and 6. So notice now I now have my diagonals are 1s, 0's below and 0 above. This is the inverse of your 3 by 3. Okay, so what's the big deal? We found the inverses. Whoop-de-doo. Those of you who did your homework last night, not quite half of your homework is done for tonight. Because what you need to do is you have to have your inverses to solve some problems. So, let's explain what it is we're doing. On a simple set of terms, yesterday we did something like this. It was a problem close to this. What do I multiply by to solve this problem? I multiply by 1/8. What did we say 1/8 was? What do we call that? The inverse. So you multiply both sides by the inverse. Well, aren't we finding inverses today? Okay, now when we did this, that gave me the identity. 1 times something, it gives me what I'm looking for. So this is the identity. If I multiply this original matrix times that inverse, this becomes the identity matrix, right? That's what we learned yesterday. The thing is, what is the other side? We don't have the other side. I didn't show you an equation here. So let's look at an equation. Let's take a look at, well, let me finish this thought here. So when you multiplied what that was equal to times that inverse matrix, it told you what your answers were. So let's take a look at a problem. This is a problem that's just basically given. I'll write it over here. So 3x plus 4y equals 10, and 7x plus 9y equals 20. And you learned this a couple sections ago. How do I make this into an equation matrix, a matrix equation? So what you do is you take your coefficients, you multiply it by your variables. How do we multiply? You take row times column, right? and you add the products together. So 3 times x, 3x, plus 4 times y, 4y, equals the 10 and the 20. This is a matrix equation. The coefficients, the variables, and what they're equal to. You now have set up exactly what we have here with the 8x equals 32. How do I solve this? The exact same way you solved this. Now, what did you do yesterday? Yesterday in your notes, I gave you this, and we figured out what the inverse of the 2 by 2 was. What was the inverse? You guys remember? If we multiply both sides by the inverse, here it is, it's negative 9, 4, 7, negative 3. That was the inverse. If we multiply both sides by this, so multiply this times that, we should get our answer. Didn't we get the answer when we multiplied the right side by the inverse? We got the answer. That's the same thing. If I multiply these two together, I get the identity matrix times x, y equal to what I get here. So I'm going to write this out. Negative 9, 4, 7, negative 3 times the 10, 20. I can't put the 10, 20 first. Why? Huh? Yeah. How do you multiply matrices? It's the row, these 2 entries, times the column. This has to have 2 entries in it. If I do this times that one, this row has 1 entry in it, and the column has 2 entries in it. So I have to have this in the front so that you can do this. Now everybody multiply this together, because you need to understand how to multiply matrices. And you've already done that. You did that in section 4. You have a question?
No.
Stage, what do you get?
10.
This is negative 90, and 80 is negative 10. 70 and negative 60 is positive 10. Okay, so what did we find? I want you to look at this. Here's your basic equation. You multiply both sides times the inverse. It gave you your answer for what your variable is. Here you have a matrix equation. You multiply both sides by the inverse. The answer gives us what the variables are. So this is your x and that's your y. X is equal to negative 10, y is equal to positive 10. So you found all those inverses of what, 9 through 12. You're going to use those answers and you're going to multiply what the answers are equal to solve for x and y on 21 through whatever it is, 31. Instead of taking this and finding the inverse again, you did that last night. Now I'm asking you to take the inverse, multiply it by the answers that you have in the system to tell me what your x and y is. Now, why is it important that we know how to do this? Well, in Algebra 1, Algebra 2, and in part of PreCalculus, you're given systems of 2 equations and 2 unknowns, systems of 3 equations and 3 unknowns. And you kind of know how to do that. You can do substitution, you can do elimination, you can even do graphing. We've talked about that, and it got kind of difficult. With matrices, you don't have to stop at 3 variables. You can have as many variables as you want. It's the same thing we were talking about when you're talking about different lines in a factory or different production lines in whatever it is your business is. You have all these different variables. Well, if you can set these up in a mathematical format with matrices, you can solve lots of different types of equations. That's the point of this. We are going beyond just basic high school mathematics with this thought process. So this is a very useful tool to have if you're going to be in that line of work. Okay, so I I want to make sure, I'm going to do one last thing and then we'll stop. I want to make sure we really have this multiplication thing down. So I'm going to, you don't have to write this down in your notes, but we can put this in the video to make sure everybody's on the same page. You've got to be able to multiply correctly. And I know we still have people struggling with multiplying bigger matrices to get it. Now this is important that you can do this. Let's go ahead and prove that this inverse is the inverse of that matrix. So we have 4, 2, 3, 3, 3, 2, 1, 0, 1. That's the first matrix. If we multiply it by its inverse, we should get the identity. Let me make sure that inverse is correct. 3, negative 2, negative 5, negative 1, 1, 1, and negative 3, 2, 6. I'm just going to go through a couple of these just to make sure you have this. If you already know how to do the multiplication, you're good at it, just relax and enjoy the show. Okay? Everybody ready? Alright, so you're going to take the first row times each column. So row 1, column 1, row 1 times column 1 is going to give me row 1, column 1's answer right here. So 4 times 3 is 12. I'm going to write down here. Plus 2 times negative 1 is negative 2. Plus 3 times negative 3 is negative 9. That answer goes right here. Row 1, column 1. So that's 10 plus negative 9 is 1. And that's what we wanted it to be. Right? We want it to be the identity. Alright, so row 1 times column 2 is going to give me row 1, column 2's answer. So this, I'm just specifically saying this for those of you who are still struggling. So 4 times negative 2 is negative 8. Plus 2 times 1 is 2. Plus 3 times 2 is 6. That gives me this answer. That's negative 6 and positive 6 is 0. We wanted it to be 0. How do I get column 3's answer? Row 1 times column 3. 4 times negative 5 is negative 20. 2 times 1 is 2. And 3 times 6 is 18. Negative 20 plus 2 is negative 18. And positive 18 is 0. So that's just to show you how to do that. Now how do I get row 2's answers? I need to use row 2 to start with. And this is where students got confused. They weren't sure what to do. Okay, so row 2 times each column, row 2 times column 1 gives me row 2, column 1's answer. Ready following me? Got me? Who thinks this is easy at this point? Who's mastered it? Okay? Which is about right. We've got about 4 of you that are still looking at it, so let's talk about it. 3 times 3 is 9. Plus 3 times negative 1 is negative 3. Plus 2 times negative 3 is negative 6. This should be 0 here if this is our identity. 9 plus negative 3 is positive 6, and negative 6 is 0. How do I get row 2, column 2? By multiplying row 2 times column 2. Negative 6 plus 3 plus 4, negative 6. Negative 6 and 3 is negative 3 plus 4 is positive 1, and we wanted that to be 1. You want me to finish it? Anybody need me to finish it? Are we okay? Don't forget how to multiply. We start together. All right, here is your assignment. This, I need you to do number 8. Number 8, you don't have the answer to. That's your first 3 by 3. That's doing this stuff right here. Okay? It doesn't give you, listen, it doesn't put this into your problem. You have to put this part on the matrix. Okay? And then work through it until you get all these zeros and stuff, until it looks like this. Until the identity is on the left and your new answer is on the right. Alright, so that's number 8. 9, 10, 11, 12. Let me see what that is in the book.
Yeah, we did 9, 10, 11, and 12 last night.
Right. So you got the inverses for those, and you checked them today in the book. I showed you the answers, right?
Yeah.
So we check those. So those go with, wait, you went to 15, didn't you?
Yeah.
So,
You want to do the ones we didn't do last time?
29 goes with 17. Yep, okay, so 9 through 12, or 8 through 12 really, but 9 through 12 you already have those answers. So that goes 25, 26, 27, 28. 26, 27, 28. So what did I just do? Your inverse that you found on number 9, if you look at 25, the system of equations matches those coefficients on number 9. So what do you do to find the answer? What did we do? That last part, you took the inverse times the answers, and that gave you what x and y were. So in your notes where I showed you how to multiply by the inverses, that's what you're doing on these. You take the inverses of number 9, multiply the answers in these problems. All right, now you're doing the same thing. When you get to 29 is matched up with 17. So you're going to do you got to find the inverse of number 17, and you're going to use that on number 29 to find x, y, and z. So this is where the 3 by 3s start. And yeah, that takes a little time. 17, 18, 19. Yeah, 17, 18, and 19 is your 30 and 31. So you have, look, you really only have 4 3 by 3s where you have to find the inverses for. Okay, so it's not that difficult. I shouldn't say not difficult. It's not that extensive. Okay, it may be difficult for you, but I'm not giving you 20 3 by 3s to find the inverses for. All right, that's good.